The original lighting install in this garage consisted of 8 T12s, and you can see there's a lot of conduit associated with this. Originally, these were all daisy chained together using Romex that was strung over the rafters. Plywood was placed on top of that Romex, and things were stored on top of the plywood. So all that had to go, and all the wires had to go inside EMT. It's 12 gauge stranded with lugs on the end. What you're basically looking at here is an unsafe residential garage with 8 T12s installed for lighting. Because we want auto-on functionality in here without turning all of them on, we are adding a fixture. This has a complicated control system involving digital lines and low voltage control lines and line voltage switching control. Now, at the time I installed all that EMT, I did not pull wiring to the original on-off switch and add a three-way here, because I wanted auto-on functionality in this garage to make it safe. So I've installed a digital control switch next to this door and occupancy sensors that will cover the garage quite well. All of this is used to fire up a digitally controlled ballast that has two T5 54 watt HO bulbs in it, and it will by default come up to what the factory programmed it at, which is full. Here you can see a piece of flexible metallic watertight that is going to be used to bring both the 18 gauge power and the control line to the ballast. The installed ballast is very similar to this one. It is a Fulham Lume Energy IB107-02, and it takes an RJ12 connector for the control connection. These control connections are interconnected through an interconnecting box, which is just that, to a fancy switch. All these connections are made with RJ45 and RJ12. Because the original short address DALI broadcast OCC sensors for this system were damaged by electricians, go figure, we're going to use a line voltage turn on for the lamp. And we're going to control it with two ceiling mount OCC sensors to get proper coverage in the garage. This guy's got 225 mil output. These guys consume 14, so you can easily put 13 of them on there and still be around 80%. You can put 13 of these on here in parallel to make an occupancy sensing system using one power pack if you wish to. Here is where power will be fed to the system. You can see an interconnecting box for the digital lines. You can see a low voltage aux sensor, and you can see the power pack that's going to be controlled by dual low voltage aux sensors. This entire system will be fused down to 5 amps slow so that we can use 18 gauge for the power wiring. The other low voltage occupancy sensing device is connected through non-metallic liquid tight flex to a interconnecting box, if you will. There's no connections in here. The low voltage wiring for the power pack goes straight through, and the digital control line, which comes off this fancy switch and is a RJ45, has its excess coiled up in this box. It's then carried over to the interconnecting box for the whole system. Now, I have temporarily installed the digital control lines to the digital box so that we can test the digital dimming. And we can see that the digital dimming control is functioning just fine. It's taking it through all of its stages, and it has digital continuous dimming. Okay, I have my 18 gauge allowed because I'm fused down to 5 amps power wire and my digital dimming connection all wrapped in tape and I am going to push it through the conduit system and allow it to come out the other end where I have an open end of LFMC. Is this what code expects from a job? No, they don't want you to leave the LFMC open on the other end. But if you ever worked with liquid tight flexible metallic conduit, which is metal on the inside and plastic on the outside, you will discover that it is very hard to get it through connections. So, as we know, our conduit install meets code. I'm going to leave the other end open, so that makes it an easy push.